Orthogonal circles.
The angle between two circles is the angle between the tangents at their points of intersection. If the angle between the tangents is 90 degree, then they intersect orthogonally, or they are said to intersect orthogonally, and the circles are called orthogonal circles. So let's say we have this circle and let's draw another circle. Now how do we actually do that? We have to create or draw lines, right? So let's draw this. So first let's draw the 90 degree lines, perpendicular lines. Then based on that we can draw or move these circles. So does this look perpendicular? Yes. Yes. Now let's move these. So let's move these. Okay. So here you notice that this is the center. This is the center. So let's say this is A, and this is B, and this is P. So now what happens? AP, let's say this is S1 and this is S2. AP is a tangent at P to S2. PB is the radius through P to S2. Similarly, BP is a tangent at P, not to P, at P or through P to S1, and AP is the radius through P to S1. If you look at the length of the tangent we saw in previous sessions. So therefore, if two circles intersect each other orthogonally at P, then the angle between the radii through P is.
Let's
figure out the condition for two circles to be orthogonal. So let's say S1 is x square plus y square plus 2gx plus 2fy plus, now here there are two circles, so g1 f1 and c1 equal to 0. S2 is x square plus y square plus 2g2x plus 2f2y plus c2 equal to 0. Now here the center of S1, let's say A, is minus g comma minus f, g1 and f1, and center of S2, let's say B, would be at minus g2 comma minus f2. Now R1, the radius of S1, would be g1 square plus f1 square minus c1. R2 would be square root of g2 square plus f2 square minus c2. Now we know that angle APB is 90 degree. So Pythagoras theorem, AB square is equal to AP square plus BP square. Now length of AB is this. AB we can figure out through coordinates itself, right? And we know the coordinates. Okay, so AB would be minus G1 plus minus G1 minus G2 square plus minus f1 minus f2 square is equal to, now AP square is what? AP square is nothing but the radius. BP is also a radius. So R1 square plus R2 square. Okay, minus G1 plus G2 square plus minus F1 plus F2 square equal to R1 square plus R2 square. Okay, G1 square minus 2G1 G2 plus G2 square plus F1 square minus 2F1 F2 plus F2 square is equal to R1 square. Now R1 square, R2 square, again we can do substitution. R1 is G1 square plus F1 square minus C, going to be for this, plus square root of G2 square plus F2 square minus C1 and C2 square. Now here's square root and square will cancel. G1 square minus 2G1 G2 plus F1 square, G2 square, missed it, G2 square plus F1 square minus 2F1 F2 plus F2 square is equal to G1 square plus F1 square minus C1 plus G2 square plus F2 square minus C2. And here G1 square, F1 square, F1 square, G2 square, F2 square, all these get cancelled, and we are left with minus 2G1 G2 plus minus 2F1 F2 is equal to minus C1 minus C2. Minus, we can multiply the entire thing by minus 1 and we get 2G1 G2 plus 2F1 F2 equal to C1 plus C2. So if two circles satisfy this condition, then they are orthogonal circles. Okay, now let's see how to find the circle cutting orthogonally a given circle. So here a circle has already been given to us. So let's say this is a circle that has been given to us. Now what we have to do is find the circle which cuts this circle orthogonally. So let's say this is the center. So let's say this is the radius. Okay, so let's say this is P, this is a point P, and this is the center, right? Now here, let's say this is S1. S1 is a circle with center as C or center at C. Now angle PTC is equal to 90 degree, right? Remember the tangent is, and PT is tangent to S1 at P. Remember, this is because tangent is perpendicular to radius at that point. The circle at P, so treat P as the center and the circle at P as center and radius as PT will be the circle cutting S1 orthogonally. Okay, so here what does this mean? You treat this as the center and the length of this tangent as the radius and draw the circle. You will get the circle which cuts this circle orthogonally. Okay, what about two circles? So find a circle cutting orthogonally two circles. A circle with any point on the radical axis of the two circles and the length of the tangent from the point to either of two circles as radius cuts both circles orthogonally. So basically this is a circle and this is a circle and this is the radical axis. Take a point on this and let's say this is the tangent and this is the tangent. Treat this as the center and the length from here to here, length of the tangent as the radius, and draw the circle. Okay, now what about three circles? So similarly, the circle with radical center is the center of or the point of intersection of the radical axis of the three circles taken two at a time. So radical center of three circles as center and the length of the tangent from it to any of the other circles as radius cuts the three circles orthogonally. So let's say this is one circle, this is another circle, and this is another circle. So this is the radical axis of these two circles, this is the radical axis of these two circles, and this is the radical axis of these two circles. This is the radical center. Now choose any one of the circles, let's say this one, and take the tangent. Remember, there can be only two tangents from a point to the circle. Take the length of the tangent, treat that as the radius, and draw the circle. That would give you a circle which is orthogonal to all the three circles. Okay, so that is orthogonal circles. That's it for now. Bye.